Welcome to Applied Lab 35 using network sniffers, and we're going to use Wireshark to capture and display some information in our Kali Linux environment. So let's begin. So first thing that you're going to do is log into the Kali Linux virtual machine with root and password. I've already done that. Now, you're going to launch Wireshark, and how you launch Wireshark is you're going to click this icon here. You can expand the hints for guidance. But I will also guide you that way. And you're going to type Wireshark in the search field. It'll come up, you're going to click on Wireshark, and I already have Wireshark maximum, so you'll just maximize the search field to where it takes up the whole screen. We've launched Wireshark. Now, we already maximized it, but we're going to do a capture on ETH0 interface. So what you're going to do is you're going to look at this ETH0 interface and double click on it. This interface is already in promiscuous mode, which Wireshark needs if you're using it on Windows in order to capture packets. Promiscuous mode puts the network card into a listening state, so where it's listening, as you can see, it's listening for traffic on the network. Once you've completed this, you can check off step 3. And we're going to go to step 4. Step 4 requires us to go to the structurereality.com website, and we're going to use Firefox for that. So we click on Firefox. And we're going to type in www. In the Firefox, and as you can see, our website comes up. So we can go ahead and check off step 4, and now we're going to stop the network capture, and we're going to stop the packet capture by going back into Wireshark, and you can minimize this. Now you're back at your Wireshark capture screen. So now we need to stop the capture, and the icon is this red square to stop the capture. Once you click this, the capture has stopped. You can check off step 5, and we can select the first packet in this frame right here. And this will tell us what we see as far as this information. So select it. The middle frame will tell you information known as packet details of the information in it. So we use Wireshark to capture frames, and it displays a simple filter for HTTP traffic collected and attempted to initial request through the Structure Reality website. And as we can see, we can look at this information and we can see the IP address of Structure Reality. We can also see that it's using an IPv4 address. We are going to expand these hints for guidance here. So at the top of the Wireshark window in this field, enter HTTPS. And you do that here in this display filter. Once you do this, we have to hit enter. I meant HTTP. So now we have our HTTP information. A simple display filter will hide all the capture frames except those including this. So if you're doing a big capture on network traffic, you can use specific filters such as certain protocol filters to display the content. From a simple display, we can see that the HTTP content is layer 7 of the OSI model. So we will see this information here. Scroll to the top to see the initial packets, and it will have the lowest value in the column. The source address of the requested is 10. Source request of the information is 10.1.16.66, and we should see this address in one of these frames. And you can see it right here. There's the destination, but also if you go up to the top, there's the source right here, and we see the destination, and this is actually our reply from the source to our destination, so we can hear the information on it. The selected display frame, which has a source address protocol, also has what we call a GET statement in here. You can see the info right here, just going through this, and it's HTTP 1.1. By selecting the captured frame at the top, we can see in the middle frame here our information that we may want to look at, a little detailed information, such as we can see that it's using an IP version 4. We can see that there is a transmission control protocol being used here, as well as hypertext transfer protocol, HTTP. You notice the Windows has everything here. It has hexadecimal information. This is the raw ASCII data captured, and this is the interpretation of that. So if you look in the ASCII interpretation, we can see that host that we can see structurereality.com in the 5th, 6th line, and the hex label was offset. We can see it starts here and then it goes to here. So we have a question: what is the IP address of the Structure Reality website? And that is 172.16.0.201. That's 172.16.0.201. And let's go ahead and score this, and congratulations, we did this. We use Wireshark to determine captured information. Any DNS information communication was captured. So what we need to do is go up here to clear the field, and we click that X to clear the field. And then what we can type in here is DNS. And then we hit enter, and we can see that our protocol is shifted to DNS entries. So if you're doing this, make sure you check off everything above our lines. So I am checking off 6 and 7, and we are going to work on 8 and finish this one up. So right now we have the clear filter button. We've already done that. We've entered DNS in our filter, so we see that the protocol is listed here in the under the protocol column of DNS, and we can look at that's the display filter arrow. If you want to select the clear display button, and we're done with step 8. We're going to go to step 9, and we're going to leave Wireshark and Firefox window open for the next exercise. We're going to confirm that we've done this. This is basic navigation, and now we're going to use display filters more. So we've already connected, we've already logged into our Kali Linux environment, and we've signed in with the root, and username is root and our password. So now we can check this off. Now we want to use Wireshark to capture new information and then visit. So we are going to start the capture again. We're going to start a new capture. This button looks like a shark fin. As you can see right here, there's a shark fin. We can start capturing packets right now. And it's going to ask us if we want to continue or save. We're going to continue without saving. And then we are going to switch to Firefox. And I am going to minimize mine. I think I'll have to open them. If I didn't, I'm sorry, I didn't do that. We're going to go here, and then we're going to type in dvwa.structurereality.com, and we're going to hit enter. Once we're here, we're going to stop the capture. So what I'm going to do here is click on this shark fin to switch over back to my Wireshark capture, and I'm going to stop the capture by clicking the red square. Now we've stopped the capture. We are done with step 2. Going to step 3. Always like to expand these hints for guidance so that we have this available so that you can also follow along. So step 3, we're going to apply a display filter. Again, as we talked about, we have to just type it up here and then hit enter, and then we see our IP. The note here is to make sure that you're not typing period. It's for the grammatics. You just need to type in IP and then hit enter. And then we're going to see our filter display from the drop down. I just typed it in, so we're going to see this information. And there's our information from hitting it in. We're going to look for, we're going to scroll down, and we are going to select IPDST. If you're unable to find the IPDST, you can type IP.dst, and you can get a little bit refined search on the filter, and you can apply it. So we're going to continue typing in our search field on this next step, and we're going to put a double equals, and we're going to put an IP address here, 10.1.16.1.16.66, and we're going to hit enter. And that's going to filter this information. So it should look in IP.dst double equals 10.1.16.66. And make sure you hit enter to select that on the keyboard. Once you put enter the display, it should filter everything in this field, in this top field for that information. So we can select 3, and we can go on to 4. We should now see the display capture of frames that include the IPv4 address of 10.1.16.66 in the destination field. As you can see right here, we do see that information. So what we're looking for was IP.destination, and just that information. And what we're saying in Boolean logic is double equals to refine the search to look for this address. So instead of pulling everything. So now we're going to create a new display field. We're done with step 4. We're going to look for the time to live value, or TTL, and if it's below a certain number. So we are going to clear the field by clicking the X, and then we're going to add a display field. We don't need to add the IP. So it says to type in IP. So we're going to type IP here. And we're going to see the sub-elements in this. So we are looking, IP filters are displayed in this window here. We're going to continue typing T on our keyboard. And what it should have been was IP.TTL. And that should have came up. Well, actually, just typing TT will bring it up. And then you hit enter. Before you do that, we want to look for a value. So these can refine our search by entering a time to live that is less than 128. So our field should look like this: IP.TTL greater than less than 128. Hit enter, and we should see this information in our field here. So we can go ahead and check off step 5, and now this frame capture should show everything in here. Remember, there's a bunch of fields in here. Time to live less than 128. We can see that here under time. And we will have to scroll down and look a little bit, and as you can see, it's been anything greater than is going to be highlighted. So we're done with step 6. If you keep looking around, you can invite you to look around in Wireshark to get familiar with it and experiment with different filters. After the display filter, so we're going to look to display ARP information. So we are going to add to this filter another layer of refinement. So we're going to type in the word OR, again another Boolean logic, and then the words ARP. And now we are going to see our protocols of ARP and anything that has a TTL less than 128. So we can check off step 7, check off step 8, and we are going to create a new filter that is going to show us IP address, anything that has the IP address of .66. I'm just going to shorten it down. 10.1.66. So what we're going to do is type in this field. We're going to clear it first. And then we're going to type in IP.addr, and we're going to look for a exclamation mark and then an equals. So we're going to look at that, and we're going to refine this here. 10.1.16.66. Hit enter. And we do not see any information. No results were captured. So we are done with steps 9 and 10. So we don't see any information that contains this. So we are going to display another filter to look for the fin flag. So we cleared the display field, and we're going to, So for our fin flags to be displayed, we need to type in TCP. So we're typing TCP at the top, and then we're going to look for, or we can type in, we know it's flags, so let's look for flags. And then we need to look for fin. So as you can see, it's a little right here. We have fin, we hit enter, and then we can filter that expression, and it could take a little bit of time. Mine came up really fast. And the steps for guidance are just guiding you down the list. We had to use tcp.fin.flags.fin in order to get this information. We do need to refine this a little bit more, so we're going to add 2 double equals, and we're going to look for 1. And we should be seeing the information we have here. So as you can see, the information will contain fin and a. We see we have fin flags that are displayed in those captures. So now we need to ask a question here. So what are these fin flags? What is the IPv4 source address of the system in the first flag? So the first flag that we have here is what, 10. 10.1.16.66. So let's check to see if we scored this correct. Yes, we did get a correct scoring on this, and we just scrolling up to make sure that we have these checked off. So next, we need to modify the display filter to remove the the acknowledgement flags. So let's expand this for a minute. And so we're going to look and enter the AND statement to this. So we're going to go here and type AND, okay, because this allows for Boolean logic to happen. And we're going to type in TCP space TCP, and we're looking for dot flags, and we're going to look for ACK here, and then we're going to enter A for acknowledgement, and then we're going to look, we're going to leave the construct here, should be with equals or space double equals 1. Okay, this, if we want to include this, it'll show, hey, this is what we use. The one flag will bring up any result that has a AK, but we don't want the AK. We don't want it to be in this set of information. So we're going to enter 0 so that it's a null value. And then we're going to hit enter. So our results are going to be empty because we're looking for nothing. So we're going to we already applied the display filter, and so we're done with step 13. We can go to 14, and as you can see that we weren't expecting any information to come up with this, so we can go ahead and click on step 16. Now, we want to display the filter frames with fin, but not sin, so are not set. So we're going to explain the hints for guidance here. And we're going to look at this information. Now we're going to replace AK, and we're going to look for sin here on our list. Now I'm going to hit that. I'm going to hit the enter button, and we're going to see the information, okay, that we're looking for. So let's go ahead and check off steps 15, 16, and 17 requires us to clear the display filter and to stop we already stopped it. If the capture is still running, you're going to stop it. I already stopped it. And we're going to leave the Firefox and the Wireshark windows open. And we're going to confirm all this information and now go to stream. So we've already connected to the, in step 3, activity 3, we're going to already, we've already connected to the Kali Linux virtual machine, and we already have Wireshark continued with the capture from the previous exercise. So we're going to use a display filter to look for the first frame that has the DVWA structreality.com in the TCP stream. So let's take a look at this. What do we need to do? First thing that we're going to do is clear our filters, and we've cleared the filters from the previous information. Remember, this doesn't, we don't have to start the capture. So if you close this, you're going to have to redo the following steps to get the previous capture. So once you have this capture information, we can actually display the filters. So what we're looking here is for TCP information. So we're going to look for TCP, and we're going to TCP. And then you're going to hit enter. So TCP contains, quotes, this information, and we're going to look for it. So what we're going to do is use analyze up here to select, and we're going to select follow all the way down here. And then we're going to look at TCP stream. Now we're giving this information here. So we're done with step 3, and we notice how the presentation of the segment is in the payload, and we can see it all in this format. You need to notice the color codings surround the TCP segments are surrounded in red and blue for the server, presented in the communication chronological order. So as you can see, we have, this is our first part, and then this is our second part of our stream. We're going to check off step 5. We can close the stream window, and then we're going to open a follow HTTP stream from the frame containing the TCP request from plainenglish.co.uk. So what we're going to do is expand this, clear the filter, not the information, and we're going to add, we're going to clear the filter and then type HTTP, and we're going to press enter. This is going to give us this information. So now we want to analyze this, so we're going to go to analyze, follow, and we're going to TCP stream. So now we see the streaming information, and we see that how it's compressed or encoded is now visible in plain text. So we're going to see this ASCII information in plain text. So what we want to do is attempt to locate in the HTTP stream the segment that says, "Welcome to DAM Vulnerable Web Application." So let's take a look around in this information here. Where do we see it? I tried using this filter down at the bottom to find. It will find it, it's just not going to scroll it down, so you have to look it up and down. But once you find it, you can move on. I tried that welcome, and I'm going to try vulnerable. Scroll this all the way to the top so it will find it. Make sure when you select stream, you are selecting the HTTP screen and not the TCP screen. TCP screen is not going to give you the information you're looking for, but if you scroll down, you will find here it is, the damn vulnerable website. You can even use the filters here, and it's going to help you. Make sure you're using the correct stream field. Okay. Now we can check this off, and we can go on and expand this hints for guidance. We have the guidance here. It tells you what we're looking for that step. And now we're going to answer a question. So what color codes are you going to see? So what color and from which side is the conversation in the HTML code? So first of all, it's going to be, from the server side, it's going to be blue. And we're going to hit score. And congratulations, you've done that. You can close the HTTP stream and then confirm that you've looked at these. And we can go now to the comprehensive questions. So we have some comprehensive questions here. So what is the proper term for network communication at the data link layer or layer 2? And at layer 2, remember, we're talking about ARP, we're talking about switches, and so we are looking at frames. Okay. Switches and layer 2 devices communicate using frames. And which pane of Wireshark can be used to view the contents of the HTTP packet payload in both hex and ASCII? And for that, we're looking at the packet data. Hit score. What expression, what display filter comparison operator is used to express the concept of two values not being the same? So in here we have the exclamation mark and equals. Which of the following statements are true? Display filters are used to find packets matching specific values from captured buffer. No. Capture filters are used to highlight specific frames already present in the capture buffer. No. So I'm sorry, I apologize. I misread an answer, so forgive me for that misread. It is late at night while recording this, so I apologize, but it is display filters are used to find packets matching specific values from a capture buffer. Yes, it is correct. Sorry about that. My bad. I was reading ahead, so I apologize for that information. What is the primary factor that determines the head payload information that can be viewed through a network buffer, through a network sniffer? And that is going to be encryption. And we're going to hit score, and we are done. You can go now to the next part that's graded. Nope, we're not going to extend this lab anymore. We already finished. We can hit yes, and we should get 100%. Sorry about the faux pas. Apologize. It's a little late at night for me.